Welcome to the Explainer. Today we're putting the official Pearson Edexcel November 2023 Higher Paper 3H mark scheme under a microscope. Specifically, we are forensically deconstructing question 1. We're going to look at the exact wordings, the specific acronyms, and the uncompromising rules laid out by the examiners for this particular mathematical hurdle. Let's get right into it. So boom, 4.68 times 10 to the power of 5. No warm-up, no preamble. This is the exact required output for Part A of the question. When you look at the mark scheme for this paper, this number isn't just a suggestion, It is the definitive, solitary target the examiner is looking for to actually award you the mark.
Section 1. Question 1. The exact answers.
Now, taking a look at the exact wordings from the mark scheme for Parts A and B, what's instantly striking here is just how remarkably brief it is. I mean, for an entire question on a higher-tier GCSE math paper, the awarding body gives examiners just a few sparse columns of text. For Part A, the answer is exactly 4.68 times 10 to the power of 5. For Part B, it's 0.005037. Notice the additional guidance column? It's completely blank. There are no paragraphs of alternative methods or partial credit scenarios. That blank space is actually incredibly telling. It literally means there's absolutely no room for interpretation. The answer column gives one specific numerical string for each part, and that is exactly what the marker must see.
Section 2. Decoding Part A. By isolating just the first half of the question, the examiner's intent becomes crystal clear. The mark scheme dictates 4.68 times 10 to the 5th power. Because of the strict coding we'll uncover in just a minute, there are absolutely no alternative decimal formats accepted in that primary answer column. Even if a student writes 468,000, which sure is mathematically equivalent in value, the definitive answer the marker is explicitly instructed to look for on the answer line is this exact scientific notation. It forces a mechanical precision. It doesn't care if you understand the broader concept, it demands total compliance with the specific format asked for.
Section 3. Decoding Part B. Moving to the second half of the question, we see the exact same structural demands. The framework doesn't loosen up at all. The exact decimal string for Part B is 0.0005037. You've got to pay really close attention to the specific placement of those zeros and the precise digits at the end, because this is the singular path to credit. The source material doesn't give a range of acceptable rounded figures here. It demands this exact translation from scientific notation back into an ordinary number. Think about it. A tired student an hour into the exam could easily drop that final 7 or accidentally miscount the zeros. It happens all the time, right? But the mark scheme offers absolutely zero mercy for fatigue. Every single digit matters, and being off by just one placeholder means losing the mark entirely.
Section 4. Defining B1 and CAO.
Let's translate some of this exam shorthand, because knowing the numbers is really only half the battle. The crucial point here is the official definition of the B mark, taken straight from the general marking guidance. It states B unconditional accuracy mark. And listen to the phrase right next to it in parentheses, no method needed. The 1 in B1 simply means the question is worth a total of 1 mark. But that B, that is incredibly powerful. It means the examiner isn't looking for the journey. They are solely focused on the destination. You do not have to prove how you got there to secure this specific point. It's a huge departure from the classic math teacher mantra of always show you're working, right? The awarding body is explicitly telling markers that the method is entirely irrelevant for this specific hurdle.
And right next to that B1, we have CAO, which stands for Correct Answer Only. This just completely reinforces the absolute strictness of the mark scheme. For this specific question, process and partial methods offer zero safety net. If you write down a fantastic, logically sound method in your workspace, but you make a tiny slip at the very end so your final answer doesn't perfectly match the one on the answer line, you get 0 marks. It's a completely all-or-nothing scenario. That unconditional accuracy demands a level of ruthlessness from the examiner. They literally cannot reward your good intentions or your nearly there calculations.
When we put Part A alongside Part B, it confirms that the exact same stringent, uncompromising rules apply to both. Both are governed entirely by B1 CAO. So whether you are converting into standard form or converting out of it, the examiner's approach remains uniformly rigid. You must be completely accurate, and your method simply won't save you if you're not. It really beautifully illustrates the consistency of the exam board's expectations across different mechanical math skills.
Section 5. The Final Verdict.
This overarching law is pulled directly from the general marking guidance.
It says, questions where working is not required. In general, the correct answer should be given full marks. This exact phrasing validates the answers only approach for this specific question. It is the official justification for why B1 Cal exists in the first place. Think about this from an exam strategy perspective. If the question doesn't explicitly ask you to show you're working and it only carries a single mark, the perfectly correct final number is the only thing standing between you and full credit. So if you know the answer instantly, you shouldn't waste 3 valuable minutes writing out a complex proof. Just deliver the answer and move on.
And I really want to remind everyone that the guidelines we've been breaking down today aren't just, helpful advice from a tutor. This is the literal official blueprint from the awarding body Pearson Edexcel. This is the exact rulebook the examiners have to follow when deciding whether you get the marks or not. Understanding this specific framework gives you a massive advantage in how you allocate your time and energy during a stressful exam. It completely demystifies the grading process and puts the power right back in your hands.
Which brings us to a final thought for you to take away from this explainer. Does the explicit rule of no method needed and correct answer only make a math question easier because you can just skip the tedious proofs and jump right to the end? Or does it actually make it infinitely less forgiving because there's absolutely no partial credit to catch you if you fall? It's a fascinating double-edged sword. Think about the true weight of absolute exam precision the next time you see a seemingly simple one-mark question. Thanks for joining me on this deep dive, and keep bringing that focused energy to your learning.